right, this next section is all about lines. So a lot of this is going to be review from what we know about lines from Algebra 1 and Algebra 2. We're just going to kind of cram all this into one section here. So first, just remember that the slope of a line is rise over run. Okay, what that means is how far we're, or how much we are changing in y over how much we're changing in x. Then the formula that we use, given 2 points, and we can call those points x1, y1, and x2, y2. Then our formula is y2 minus y1 over x2 minus x1. All right, now, as we get up into higher levels of math, it's better to think of slope as a rate of change. Okay, a rate of change, how fast one variable is changing relative to another variable. All right, now we could see slope written a few different ways. We just talked about a few of them. All right, m is usually the variable we use, but we could see it written as rise over run. We could see it written out as change in y over change in x. We could see it written using deltas, right? Delta y over delta x. And with this, okay, a calculus kind of notation for slope is dy over dx. We may see it written just using our formula, y2 minus y1 over x2 minus x1. Okay, so lots of different ways that we may see slope expressed mathematically. All right, so the different types of slopes that we might encounter. All right, we could see a positive slope, right, or an increasing slope. Right? We could see a decreasing or a falling slope. We could see a horizontal slope or a zero slope. We could see a vertical slope, right, or undefined slope. Right, so let me write those down real quick here. Right, so this one we said was a positive slope, and we can tell that on the graph, okay, because the line is rising from left to right. A negative slope, right, and we can tell that because the line is falling as we look at it from left to right. Okay, this is a zero slope. Right? So a zero slope is a horizontal line, and then this is a vertical line. We say it has an undefined slope. All right, now, the greater the absolute value of the slope, the steeper the line. Okay, so if our line has a slope of 1, okay, it would look actually something like this. If the line has a slope of 2, it's going to be a little steeper. A slope of 3, even steeper. Okay, and we can say the same thing about negative slopes as well. Right, a slope of -1, slope of -2, slope of -3. It keeps getting steeper and steeper. All right, so real quick, let's just try finding slope through a couple of given points. Right, so we'll plug these into our formula. y2 minus y1 over x2 minus x1. Right, so we label the points, right? x1, y1, x2, y2, and then we just plug them in. So y2 minus y1 is going to be -3 minus -2. So we got to keep our negative signs straight. So I always use parentheses when I'm substituting in a negative number. Then x2 minus x1 is going to be 2 minus 3. So -3 minus -2 is -3 plus 2, which would be -1. 2 minus 3 is also -1. So a negative divided by a negative is a positive. Now, Since we are talking about slope, okay, we usually like to leave it as a fraction, even if this works out to a whole number, so that we can see our rise and our run. So I'm going to leave this as 1 over 1, even though obviously that would just reduce to 1. Okay. Now, it says state whether the line is rising, falling, horizontal, or vertical. Since we get a positive value, that means that our line is rising, okay, positive slope. All right, so why don't you guys take a second and try this one. All right, so same idea. Label our points, x1, y1, x2, y2, plug them into our formula. So y2 minus y1 will be 4 minus -4 over, I'm sorry, -4 minus -4 over -1 minus 8. So -4 minus -4 would be -4 plus 4, which would be 0 over -9. So if we get 0 in the numerator, okay, that means there is no rise. That means we would have a horizontal line. Okay, so whenever we have a slope of 0, we get a horizontal line. All right. So the next little idea here is just our 3 basic equations for a line. All right. I'm sure you've seen these before. The point slope form of a line is y minus y1 equals m times x minus x1. All right, and this one is actually probably going to be the one that we use most often when solving problems. Right? Now the slope-intercept form of a line, y equals mx plus b, right, this is probably the one that you're most familiar with, where just by looking at this line, you can see the slope and the y-intercept. Right? And the last one is probably the one you're least familiar with. Right? The general form of a line is ax plus by plus c equals 0, where a, b, and c are integers. Okay. This one is actually useful for finding intercepts of a line, right? But it's probably the one that we'll use least often. Right? We will use these 2 forms of a line most often. Point slope, if we know a point and the slope, and slope intercept, if we know the y-intercept and the slope. Okay, so let's take a look at a few problems here. Okay, first one, let's write an equation in slope-intercept form of a line that goes through the point -1, 0 with a slope of 2 over 5. Okay, so whenever we're given a point and we are given a slope, we probably want to use point slope. So point slope is y minus y1 equals m times x minus x1. And what I'm going to do, my point is going to be x1, y1, and then obviously my slope is m. So I'm going to plug those 3 values in here. I'm going to say y minus 0, my y is 0 here, equals 2/5 times x minus -1. So since it's minus -1, that would really be plus 1. And then I can simplify a little bit. Obviously, this would just be y. So then I can distribute my 2/5 through and get 2/5 x plus 2/5. Okay? So whenever we're given a point and the slope, I'm going to use point slope and plug in x1, y1, and m. Okay, so this would be my final answer here for part A. For part B, we want to find the equation of a line that just goes through these 2 points. So uh, if we're given 2 points, we can always find the slope. Right? So let's start by doing that. Right? We know that we're going to need the slope at some point. So m is, let me label my points, x1, y1, x2, y2. So my slope is y2 minus y1, which would be 3 minus 1, over x2 minus x1, 1 minus 0. So that'll be 2 over 1. All right. So now what I know is the slope, and I have 2 different points now. Okay. What I'm going to do, I'm going to plug one of those points into my point slope form of a line. Okay. It does not matter which point I choose. I can choose this point or this point. Since I already have this one labeled as x1, y1, I'm going to go ahead with that one. So if I plug that in, I'm going to have y minus 1 equals my slope of 2 times x minus 0. So this will just become 2x over here. I can add my 1 over, and I get y equals 2x plus 1. Okay, now, small shortcut that could have saved us a couple of lines of work. Right? Once we find the slope, this point here is actually the y-intercept. Since it has an x-coordinate of 0, this is my y-intercept for the line. If I was able to recognize that, I could have actually jumped straight into y equals mx plus b and said, well, I know my slope, I know my y-intercept. The final answer is just y equals 2x plus my y-intercept of 1, okay, which is what we got using point slope. Okay, but that's just, something to pay attention for. See if we're actually given the y-intercept, and we could just jump into slope-intercept instead of point slope. All right. So next idea is just special equations, which would be horizontal and vertical lines. So a horizontal line, okay, every single point on a horizontal line would have the same y value. Right? So if we say that the point HK is on these lines, we would say that it's going to have the exact same y value. So I'm going to say the equation is y equals whatever that y coordinate is. Okay, so I'm going to say it's y equals k. Vertical lines will every point on a vertical line will have the same x value. Every single point will have the same x value. So we say the equation of a vertical line is x equals some number. Okay? Or if we're talking about having the generic point hk, we would say x equals the x coordinate, which is h. Okay? So a couple of examples of graphs. If we have the line x equals -3, well, what that's telling me is every x value on this graph is going to be -3. So I'm going to have points here, 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 here. Right? Every single point that has an x-coordinate of -3, right? And then we will get, a vertical line like that. All right? Now, over here, if I want a horizontal line through the point 5,4, well, let's find the point 5,4. 2, 3, 4, 5, up, 2, 3, 4. So here's the point 5,4. Okay, I want to draw a horizontal line through there. Well, if I do that, every single point is going to have the same y coordinate. That y coordinate will be 4 all the way through there. Right? So what this line would end up being is the line y equals 4. Okay, so vertical lines are always in the form of x equals some number, whatever the x coordinate is, and horizontal lines are always in the form of y equals some number, whatever the y coordinate is. Okay. The final big idea in this section is parallel and perpendicular lines. Okay, so if two lines are parallel, their slopes are exactly the same. Okay, or we could just say equal. Their slopes are equal to each other. If two lines are perpendicular, their slopes are opposite reciprocals. Okay, so two parts to this, right? The opposite part means opposite signs. That means one of them would be positive and the other would be negative. And then reciprocals means just the fraction is flipped. Okay, so an example of opposite reciprocals would be like 2/7 and -7/2, right? One of them is positive, one's negative, and then we just flip the fraction upside down. That's what reciprocal means. Now, another way to say that is that the slopes multiply to -1, right? Opposite reciprocals will always multiply to -1, right? For in our example, 2/7 times -7/2. If I just multiply straight across, I would get -14/14, which would just reduce to -1, okay? So let's go through a few examples here real quick. Right? First, we just want to determine whether each pair of lines is parallel, perpendicular, or neither. To do that, all we're doing is comparing the slopes. So in this first example, both of these lines are already in slope-intercept form. Right? I've got y equals mx plus b. So the m is all I'm looking at, the slope. Right? In this case, my slope is 3. In this case, my slope is -1/3. So these two values, +3/1 and -1/3, are opposite reciprocals. That means that these two lines are perpendicular. All right. Now for this one, okay, I've got one of my lines in slope-intercept form, y equals mx, and then my b would be 0. But this one is not, okay? In order to figure out the slope of a line, it has to be in slope-intercept form, okay? The slope of this line is not 1, okay? It's not the coefficient right here. I need to solve this equation for y. So to do that, I want to get my x over to this side. Right, so I'll have 5y equals -x plus 15, and then I'm going to divide everything by 5. So we end up with y equals -x over 5, or that would be the same as -1/5 x plus 3. All right. So now I can see that the slope of this line is -1/5. So here, my slope is +1/5. Here, my slope is -1/5. These are not the same. One's positive, one's negative, but they're not opposite reciprocals either. That means that these lines are neither parallel nor perpendicular. They will cross, okay, but they will not be perpendicular. All right. So the last idea then is to write the equation of a couple of lines. First, we'll look at a parallel example, and then we'll do a perpendicular example. So first, I want to write the equation of a line that is parallel to this given line that goes through this point. Okay, well, if I want my new line to be parallel, I want it to have the exact same slope as this line. Okay, well, to find the slope of this line, I need to first put it into slope-intercept form. So all I need to do that is divide everything by 2, right? Get y by itself, and we'll get y equals 3x minus 4. So now, just looking at this line, I can see that the slope is 3. Again, since we want our new line to be parallel, that's going to be the same slope as my old line. So my new line is going to have a slope of 3, and I want it to go through the point 1, 2. So I have the slope, I have a point. We're going to use point-slope form of a line. Y minus y1 equals m times x minus x1. And this would be my x1, y1. So I'm going to have y minus 2 equals 3 times x minus 1. Now, since the directions actually just say write the equation of a line, this would be an acceptable answer. Usually, though, the directions will say to write the equation of a line in slope-intercept form. Okay, so we would want to solve for y. So first step would be to distribute this 3. So we'll get 3x minus 3 over here on the right side. Then add the 2 over, and we'll get y equals 3x minus 1. Okay, so this line would be parallel to this line and go through this point. All right. One final example. All right, I want to write the equation of a line that is perpendicular to y equals 2x minus 8 and goes through this point. Okay. Now, this line is already in slope-intercept form, so I can just look at this line and see that it has a slope of 2, right? But I want my new line to be perpendicular. We know that perpendicular means opposite reciprocal slope, all right? So the opposite reciprocal of 2 is going to be negative 1 over 2. Because remember, 2 is the same as 2 over 1. So if I flip that fraction, I would get 1 over 2, and then I need the opposite sign. So now my new line here is going to have a slope of negative 1/2 and go through the point 3, negative 4. So again, I've got my slope, I've got my point. I'm going to use point-slope form. And just plug these values in. So my y1 would be negative 4, so I would have y minus negative 4. That would just be y plus 4 equals negative 1/2 times x minus 3. So let's put this into slope-intercept form. All right, we would distribute this half first. So I'll have negative 1/2 x plus, because I've got negative times a negative, so plus 3/2. Then finally, I would subtract the 4 over, and 3/2 minus 8/2 would be negative 5/2. Okay, and this would be our equation of the line perpendicular to this line and passing through 3, negative 4. So if we were to graph this, right, it would meet this line at a 90-degree angle and go through this point. All right, so that's it for this lesson. Again, final question is going to pop up and just ask what questions you still have. All right, but we will work on the assignment for this in class tomorrow then.